Hi everyone, welcome to this lesson where we're talking about coordinate proofs, which means we're talking about proving special values on the coordinate plane. And you'll see that actually doing a coordinate proof means that we are really looking at the diagram closely. We're thinking about the coordinate plane and what values mean and what isosceles triangles and right triangles would mean to exactly be on the coordinate plane. And I know that really doesn't sound like too much, but let's take a look. So first off, we're going to follow directions here. It says position and label right triangle XYZ with leg XZ, which is D units long, on the coordinate plane. Now, I made two sketches of coordinate planes, really basic, and there are going to be just different examples that follow along with this. And of course, you could have so many different answers as well. So it says leg XZ. So I'm going to make a right triangle. All it says is that it's a right triangle. I'm going to label this X, Z, and this will be Y. And if I go ahead and I construct, I know that was a terrible line, a right triangle, I would be able to say, of course, that my coordinate at X is 0, 0. My Z coordinate, since I want this to be D units long, would be 0D. Okay, and my Y coordinate is some unknown value. Like I don't know how far I went out on the x-axis, but I do know the Y coordinate of point Y is 0. So this would be just one way to represent that example. And I could do it differently here. I could maybe say, hey, X is at the origin, maybe put Z out here, Y here, just to show you another possible example. And I'm sure everyone watching can come up with another way to set this up. But let's say X is also at 0, 0. I don't know how high Y is, but it's at 0 and some height A that I don't know. And then since this is D units long, this Z value is actually then at negative D, 0. Okay, so whatever this point is, if it's D units long, it would be at negative D. Okay, let's take a look at this one. It says, name the missing coordinates of isosceles right triangle QRS. So here, if this is an isosceles right triangle, okay, and this is also going to be an isosceles right triangle, it would mean that this QR is the same as RS. Okay, so Q here is clearly at 0, 0. R is at some point, I don't know, but I know it, let's say it's A units long and at 0. So I'm going to call this length A. And since it's isosceles, this would also have to be a length of A. So that means that point S is at A units across on the x-axis and A units up. So the coordinates of S are actually A, A. And I'm just making up A. This one here, R is clearly at 0, 0. If I want this to be isosceles, let's say I call this B. So Q is at 0B. It's B units high. S is at A units. Actually, I'm going to turn that into a B. I used A for whatever reason, and then 0 on the Y. And I know that's a little messy, so let me clean that up. I had an A there, but I just decided to change my variable to B. Okay, and so it's B units out on the x-axis, 0 units up. Now here, name the missing coordinates. So if this is an isosceles triangle, has nothing to do with being a right triangle, I have no idea, I just know it's isosceles, and this point is at negative A, 0, well, then this point here, if it's isosceles, would be at positive A, 0. All right, because if it's isosceles, then these two segments are also congruent because my y-axis is basically bisecting that entire angle and bisecting this opposite side. Up here, my point B would be at 0B, so some units B high. This one here, my A is clearly at 0, 0. This point, if I call it 3A, my Y value is at 0, and this one is just simply 0B. Oh, I have a mistake here. I don't know why I have 0. that is not supposed to be there. That was supposed to be a blank space. So let me undo that. And so my B value, let's take a look. If it's isosceles, this should be halfway, and that's a terrible halfway line, so I apologize on that. But it should be, if this is at 3a, then this is actually at 1.5a. Okay, it would be halfway through that entire segment. So if this is 3a units long, then halfway through would be 1.5a and some unknown height b. Now, a coordinate proof. It says prove that the segment that joins the vertex angle of an isosceles triangle to the midpoint of its base is perpendicular to the base. That's definitely a mouthful, but here's what we're going to take a look at. We're going to look at this diagram, and what we want to prove is that the segment that joins the vertex of an angle of an isosceles triangle to the midpoint of its base is perpendicular to its base. Basically, we want to prove that if we connect point Y to W, and we connect its midpoint to the vertex, we are proving that it is perpendicular. Now you might say to yourself, you know what, how do I prove it's perpendicular? I could see it's perpendicular. I just know it's perpendicular. But think about it. If we're on the coordinate plane, we know how to prove things are perpendicular by their slopes. So if I give you these three coordinates, 0, 0, AB for Y, and then 2A, 0, and we can see if this is A units out, then this length is 2A. We would first want to calculate, well, what exactly is the midpoint of XZ? Like, what is this point W? Okay, if this is 0, 0, and this is 2A, 0, then W would be A0. It's halfway in between 0 and 2A, and then it's just actually 0. Then I would say to you, well, okay, well, what's the slope of this supposed vertical line? And we know the slope is we subtract the Y values over subtracting the X values. So B minus 0 over A minus A, right? Because this has a point of A0 and this is AB. So B minus 0 over A minus A gives us B over 0, which we know is definitely undefined, right? Anytime you have 0 in the denominator, anytime you have 0 in the denominator, it is undefined. Anytime you have 0 in the denominator, it is definitely undefined. So I know for a fact that this has an undefined slope. Now think about what's perpendicular to an undefined slope, a slope of 0. So if I could then prove that XZ has a slope of 0 and plug in those values into my slope formula. So I'm subtracting my Y, so 0 minus 0. Subtracting my X's, 2A minus 0. I would get 0 over 2A, which is just simply 0. And then look, I have a slope that's undefined, a slope of 0. Because undefined and 0 slopes are negative reciprocals, that means that those two segments are in fact perpendicular to each other. And if they're perpendicular to each other, then of course that does mean that there is a right angle there. So creating that point W, calculating the slope of YW, counting the slope of XZ, finding they have negative reciprocal slopes, proves that they are perpendicular to each other. Thank you so much for watching this video. Bye.